our next one for today, we will be looking at how AI can help insurtechs, specifically in developing countries, to become leaders in their field. Unfortunately, we all know the feeling of damaging your vehicle, potentially damaging your vehicle by scratching it. And after this incident, the last thing you want to do is think about the burden, the administrative burden, and the processes that you need to go through. And due to this, a lot of insurers, vehicle manufacturers, everybody in the automotive sphere and community is actually looking into how artificial intelligence can help to make this process more accurate, faster, and less cumbersome for users. So Candela has been involved in Deloitte's AI car damage asset and bringing this to multiple clients really across the globe. And through her experience working with car damage and in the automotive sector, she will be discussing how insurtechs, specifically insurtechs in Mongolia, is using this from vehicle damage assessment all the way through to claim management. Candela.
Thank you, Anke. So hello, everyone. My name is Candela, and as Anke just mentioned, I'm part of the AI and data team here at Deloitte Luxembourg. My background is in mathematics and artificial intelligence, and for this session, I will be discussing how AI can be implemented in startups in developing countries to give them an advantage against its competitors. While a similar approach can be applied to many countries, and of course, AI can benefit any industry, I'll be using Mongolia's automotive industry as an example, as it is a place that is starting to see new investments in the insurtech industry. So currently, Mongolia's economy is focused on agriculture, mining, and livestock, and only around 0.13% of GDP is used for new technologies research and development. Around 25% of the population has a vehicle, and as mentioned right now, insurtech companies have been emerging as a way to increase revenue by attracting new clients, enhancing their processes, and reducing their cost. So right now, in most cases, the Mongolian insurance process is expensive. It requires specialized training and equipment. It's time-consuming. It requires repetitive tasks and a lot of paperwork. It's inefficient and it's physically demanding. For example, the evaluators of the vehicles that need to analyze vehicles all day have to be on their feet all day. So car damage recognition is an AI tool that can help with all the pain points just mentioned by optimizing the customer journey from having an accident to getting the claim reimbursement. The AI model gets vehicle pictures as input and is able to identify the different car parts, how damaged they are, and the damage type they have. So for this, our model is able to recognize 19 different car parts with 3 different damage levels. So it's either undamaged, moderately damaged, or severely damaged. And it recognizes 3 different damage types. So cracks, scratches, and dents. So how can this be implemented in the end-to-end process? So first, if we look into the current process, when the user has an accident, it contacts the insurance company and it gives it some information about what happened, when did the accident happen, who was involved, etc. So now that the insurance has this information, the user goes to a mechanic or an evaluator to look at the vehicle and assess the damages, how much it's going to cost to repair them, how much time, etc. And then once this is done, the evaluator, the mechanic, has to contact the insurance company to send them this information. And then the insurance company can use this information with some information about the insurance plan of the user to calculate the final reimbursement amount for the end-to-end user. So this whole process can take about a week, since the vehicle needs to be taken to the mechanic needs to do the evaluation, etc., etc. So it can take some time. So then with AI, the client can directly take the pictures whenever they have time and send them directly to the insurance company that can then use AI to process the images and analyze the damages, etc., and send them back to, so basically, during this process, the idea is to kind of eliminate the second step of having to take the vehicle to the evaluator, so you can save some time. So then with the AI, once it has analyzed the images, it can send them back to the user, And if the user accepts the outputs, it's like, okay, I agree with the fact that the rear bumper is moderately damaged and the door is severely damaged, then this information can also be linked to a cost database that can be used to estimate the repair cost and the repair time. So then this can be sent to the user. So of course, this process has some limitations and can only be applied to cases in which internal damage is highly unlikely, as the current model as it is right now only works for external damage. But in some cases, it can really reduce the process from about 1 week with the original process to about 30 minutes. And these 30 minutes really include the full process of the end user taking the pictures, sending it to the insurance company, the model running, etc. The model itself takes usually under 5 minutes to run about 8 pictures. So by using an AI model to assess damages and linking the output to a cost database, insurtech companies can really increase efficiency, save cost, and increase customer satisfaction. So now going into a bit more detail into the damage recognition model itself, I just described how it is implemented and what it does, but now I'll go into a bit more detail into how it was built, how we built it. So the overall model is comprised of 2 deep learning models that were trained on vehicle images from different regions and images with different lighting, different angles, etc., to be able to generalize. And the models also exploit transfer learning to apply knowledge gain on certain types of vehicles to other types of vehicles. And this has allowed us to be able to train the models on much less data that we would have needed otherwise, as the model is able to generalize to different car types and markets. Then if we move on into the repair estimation, which is another very helpful functionality, the car damage output can be integrated with the insurance systems, and different rules can be applied to estimate repair cost. For example, if the model detects a crack in the door, it can be established that the door needs to be replaced instead of repaired. But of course, these rules might change across regions. For example, some regions might prefer to repair versus replace. So this flexibility really allows the model to be implemented on different countries without the need for significant changes. Of course, some adaptations always need to be made, but the flexibility is really helpful. And then for continuous learning, it is important to first understand that the data and the business requirements change with time. We are in a highly evolving period. So the insurtech or the insurance company should always stay in the driver's seat and be able to override the model output as required. So for example, let's say that the model says that the rear bumper is moderately damaged, but when reviewing it, a human reviews it and it seems that it's severely damaged. So this is overwritten and the output ends up being severely damaged. But the interesting part is that this output that has been corrected can be used to retrain the model. So the model keeps learning and adapting to the new requirements as the needs evolve. So now here on the left, you can see a prototype of a phone application for an insurtech company that has implemented AI. So the idea is that the user logs into the application, has some information about its insurance company, and then it's able to submit up to 4 pictures from the left, the right, front, and the back, depending on where the damages are. And then the model will process these pictures and then return an output to the user. And the output is given in 2 different ways. So first, it has a written summary in which you can read the different car parts that were identified and how damaged they are. But also the output is also given in a visual format. So you can see the image with the different parts that the vehicle has, that the model has identified in the vehicle and how damaged they are. If you see a green mass, it would be undamaged, orange, moderately damaged, and then red would be severely damaged. So that's the prototype of the application. And then on the right, you can see like a quick visual video of how the model works. And you can see on the top how the model is identifying the different parts and how damaged they are with the 3 different colors.